Okay, so this is section 2.6, talks about special functions. Um, we're going to briefly talk about constant functions, identity functions, absolute value functions, and what we call piecewise functions. There's one other function we will discuss in a later video. All right, so if you look at the graph of f of x equals 3, is it a function? And how do we know? Well, because it's a graph, the easiest way to determine if it's a function is to use the vertical line test. So we take our vertical line, let me place it anywhere on the graph, and it only touches the graph in one place, right there. So yes, it is a function because it passes the vertical line test. Okay, but what kind of function is it? So because the line is a horizontal line, it goes straight across. Just delete this here. Because it goes straight across and there's really no change in it, we call this a constant function. Constant functions have a slope of 0. They are horizontal lines. And they are sometimes referred to as the zero function. So for constant functions, they're written pretty simply. So in this case, the y-intercept is at 3. So this function will be y equals 3 or f of x equals 3. You could also have y equals 4, so it will just be a horizontal line at 4. Or y equals negative 1. It could be any number. But notice there's no variables on the opposite side of the y. It's just a constant or a number. All right, so our next function we're going to look at is f of x equals x. And for this one, we can make a table of values. So I have x, I have my f of x, remember, which represents y. And we usually do 2 negatives and 2 positives, and of course 0. So if I put in negative 2, I should get out negative 2. I put in negative 1, I get out negative 1. 0, 0, 1, 1, 2, 2. Let me plot the points. So negative 2, 2, negative 1, negative 1, 0, 0, 1, 1, and 2, 2. So it should be something like that. Of course, it's a little bit off somewhere. Oh, let's get the point. Let's fix those. Negative 1, 1, negative 2. There we go. Okay? And of course, we have our arrow, so it means it keeps going on and on and on. So for this function, we call this the identity function. So whatever you get for x, you get for y. It's the same thing. and it's always written in the form of f of x equals x, or you might see y equals x. So that's what we call our identity function. Now let's examine the domain and range. What will be the domain of this function? As we read the graph from left to right, are there any numbers that x cannot be? No. So this would be all real numbers. Or we can write it our funny R. And the range, you look at looking up and down, there's no numbers. Y cannot be, and so it would have the same as the domain. So all real numbers. All right. So with the identity function, the x and the y values are exactly the same, thus making it identity. For this one, the graph is f of x equals the absolute value of x. So the absolute value of x is going to give us, okay, so for this one again, make a table of values. 2 negatives, 2 positives, and 0. So this is -2. If we plug in -2, we get out 2. If we plug in -1, we get out 1. Plug in 0, get out 0. Plug in 2, get out 2. Plug in 1, get out 1. Okay, so we go ahead and graph this. And we end up with we get a V shape. Absolute value functions always have a V shape. Okay. The domain for this as we look left to right, there's no numbers that x cannot be, so this will be all real numbers. And then my range would be looking from up and down. My graph does not go below the x-axis, therefore there are no negative values. So my y would have to be greater than or equal to 0. The absolute value function is also can be referred to as a piecewise function, in that we could write this as a function in 2 pieces. So for instance, we could say that y equals -x for values of x less than 0, and then y equals x if x is greater than 0. I'm sorry, greater than or equal to 0, because we want to include 0. Okay, so the -x is this part here. All right, so for all values less than 0, we're going to have our y equals -x. And then for y equals x, for all values greater than or equal to 0. Okay, so this is both a piecewise and an absolute function, absolute value. And that concludes this video.